Making a Stuart Models steam plant, part 47 already. The Stuart Models new 504 boiler, fitting the steam turret and finding a very unusual problem with the water gauge glass. This is the special steam turret that I made for this boiler. It seemed to be a good idea to fit the turret onto the boiler rather than use a long pipe going from the valve on the boiler down to the steam turret on the baseboard. The steam turret and the tap to which it mounts were loosely fitted to the boiler, and the time has now come to fit the parts properly. I needed to fit a couple of shim washers to make sure that the valve was in the right position and tight. And here's a clip of the shim washers on the thread adapter, and here is some Loctite 542. I always use this stuff for securing steam fittings into boilers. You must not get this Loctite product confused with the other Loctite product, which is green, called Loctite 603. That is a retainer, and if you use 603 on a job like this, you will have great difficulty in removing the parts. And to make it so that you don't get too confused, Loctite 542 is red and Loctite 603 is green. All I need for this job is the thread sealant. I've just had a quick thought, a quick nightmare. Do not use silicone rubber. Silicone rubber is okay for certain applications, but not this one. The customer in the USA messaged me and said that he didn't think this turret was going to be strong enough, and because of course the customer is always right, I will fit some more supports to the turret, even though the turret is strong enough and it will be supported anyway by the piping that connects to the engines. I will fit the extra support for the turret later on in the series. Here I'm fitting the pressure gauge siphon. This is a genuine Stuart pressure gauge siphon, and I've used genuine Stuart aluminium washers, even though I don't like them. A few words of caution: never tighten the union nut onto the pressure gauge like this. If you do it this way, you can damage the pressure gauge. What you need to do is support the part that you're screwing it to, using a small spanner on the square section. That way you can put a lot more pressure on the union nut to get a perfect seal, without causing any stress to the gauge itself. That's the turret fitted and the pressure gauge fitted. The next thing to look at is the water gauge. The customer in the USA has sent me quite a lot of Stuart parts, and as this is a brand new Stuart 504 boiler, this is the type of water gauge I'm going to use. These are brand new and untouched, possibly from a few years ago from Stuart Models. From the pack, I removed a piece of water gauge glass tubing, the two fittings and the two O-rings. Here are the two fittings. The top fitting is the one with the larger nut on the top. That's where you slide in the piece of glass tubing. The smaller nut is the blanking plug on the bottom fitting. Not wishing to be too repetitive, once again I'm using Loctite 542 thread sealant to seal the threads on these parts as they fit into the boiler bushes. You don't need a lot of Loctite 542, I generally apply too much. I've fitted a shim washer of the correct thickness to allow me to rotate the fitting tightly into the bush. Now I'm repeating the process with the top fitting. When I applied this Loctite 542, I forgot to put the shim washer on, so I did that afterwards and then tightened the whole assembly into the top bush. I've shown the fitting of water gauges in quite a few videos over the years. Most of them are different to these though. There are different ways of fitting water gauges. Some people use a piece of steel bar to align the two fittings. I don't, I use the glass. But whichever method you use, as long as it works for you, that's fine. I hadn't cut the glass tube at this stage, and to be perfectly honest, I was a little bit worried about the tightness of the tube in the fittings, especially the bottom fitting. And even before I'd cut the tube, when I started to rotate the nut at the bottom, the glass cracked, and I hadn't even fitted the rubber seals at this stage. The glass feels to be slightly too big for the holes in the fittings. In this clip, as I'm cutting the glass tubing, you can see how badly shattered the end of it is. Once I'd scored a ring around the glass, I just snapped it off cleanly like this. Yes, I know I should have used a cloth, health and safety, etc., but it's the only excitement I get in my life these days. Oddly enough, later on, when I was fitting the safety valve, I cut my finger on a piece of glass that was sat right on top of the boiler. But I didn't cut my fingers while I was handling the sharp pieces of glass on the tube. Here I'm fitting the O-ring seals, and they're going perfectly. This is a stage of the proceedings where I tighten the nuts, and you do not want them to be very tight at all. just sufficient to hold the O-rings against the glass. If you over-tighten them, the glass will break. But guess what? Even before I got this nut halfway down, the glass broke again. I've fitted many water gauges to a great variety of different model boilers, and I have broken them in the past, to be perfectly honest, but never twice, and I've never come across a gauge glass that was such a tight fit in the fitting. Here's a shot of the broken bit as I was withdrawing it. Either the holes in the fittings are too small or the glass is too big. I know, I'll get a piece out of my box of water gauge glasses. The piece on the right is the one that came out of the Stuart packaging, and the piece on the left is a piece of water gauge glass from my box of water gauge glasses. And in this image, the one that is broken is the piece that came from the Stuart packaging. I think it's time to compare these gauge glasses scientifically using my micrometer. And here's the result. This is definitely a first. The piece of glass that came with the water gauge out of the Stuart packaging is too big to start with, and it's not round. The thickness of the piece of glass tubing varies throughout the length. Whereas this piece of water gauge glass, which is out of my box of pieces of water gauge glass, is perfect all the way down. I think it's a good idea to use this piece. Using my glass cutter, I'm scoring a ring all the way round, and as before, I simply snap it off like this. Health and safety warning: wear eye protection, use a cloth or a pair of gloves. That way you won't cut yourself or get any glass in your eye. The alignment of the fittings is pretty good, and the glass goes into the bottom part easily. This time when I tighten up the nuts with the O-rings in place, the glass doesn't break at either end. With the gauge glass successfully installed, it's time to fit the cap at the top. You will note the use of the aluminium washer as supplied by Stuart Models. Copper washers are my personal preference. What about the bottom fitting? Do I put the blanking plug in this? No, because I need to fit some sort of blow-down valve, which allows the removal of air bubbles from within the glass tube, and this allows a more accurate reading of the water level in the boiler. I have a choice of blow-down valves. I can use this cock-type valve, but this one is vastly overscaled for the job, and from my experience using blow-down valves of this type, they frequently seem to dribble. I prefer to use one of these. This is a 180-degree globe valve. The threads on each end of it are 3/16 by 40 threads per inch, and that allows for a very small union nut and a very small pipe, which will take the water from the blowdown valve to the drain. And that is it for this episode. The water gauge is fitted and working. As always, stay healthy, thanks for watching, and hope you found it useful. Please take the time to visit my Mainstream Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.